Hello friends, it's David Cuartillas, co-founder of Arduino, and like every week, I'm here today from my shed making the Arduino weekly livecast. And this week I want to talk to you about a very nice trick that consists in how to connect our dear MKR1010 via Wi-Fi to a WebSocket server, what will allow you to make very interesting data exchanges in real time between your board and a application running your computer. This is a very simple example that is not exactly documented, that requires to put together a couple of bits and pieces. So I'm going to show you step by step how you can do this. First of all, you should need to understand what a WebSocket is all about. A WebSocket is a special communication protocol that runs on the same communication ports as the HTTP. So this brings people to confusion, but they are not the same thing. So WebSocket allows you to open a bidirectional communication with a really low latency between two different applications. In this way, you can use it, for example, inside servers as a way to share data between different parts. We in Arduino use it to with our Arduino Create device, so that you can create software, so you can connect the USB to the web browser. And in this particular case, we're going to use it to have a communication between the Arduino MKR1010 and a web server, or sorry, a WebSocket server made in processing, which is a free software that is freely available and that you can use for any kind of interesting data capturing projects. So we will start by having both software side by side, and here you can see them in these windows. On the left hand side you can see Arduino, an empty sketch. On the right hand side you can see processing, also an empty sketch. So we'll start by running a WebSocket client on Arduino and try to connect to an existing WebSocket server where you could send data and echo data back and see whether things work properly. So first of all, you need to make sure that you have everything installed. Since we're using the MKR1010, you need to have the MKR1010 core. I can check here whether I can configure my board, the Arduino MKR1010, on my boards manager, and I have it. It's great. If you didn't have it, please go to the board manager and install it from there. Also, make sure that I have the board on the right communication port, and you see here how the port is being identified, COM18 in this case, and I see my Wi-Fi 1010 being identified here. So on top of that, I need to make sure I have all of the libraries that I need, and in this case, you need to have the WiFiNINA library, which is the one that is used to work with the wireless communication, in this case the Wi-Fi, on the MKR1010, and you can install it by just searching for Nina in the library manager in Arduino. And here you see I have it installed and I have the latest version. That's great. On top of that, you need to have the ArduinoHttpClient library, and this is oh, I mistyped it big time. I'm doing something weird with my keyboard today. So you need to have this other library. This is called the Arduino HttpClient. And this special library has a bunch of examples that work over HTTP, one of them being a WebSocket client example. So again, I just double check I have the latest version, which I do. If you don't, please install it. And we will take as a point of departure that example with a WebSocket. So you have to go to Files, Examples, and you see here Arduino HttpClient, and there is a simple WebSocket example. You will open this example and it will look like this. I will just take it full window for it. And it was created by Tom Igo. Sorry, in first place was created by Sandeep Mistry, which is one of the developers at the Arduino core, and Tom Igo, who is a professor at NYU and is one of the Arduino co-founders. And you can see here how this library includes the HTTP client. This example includes the HTTP client library and the Wi-Fi 101 library. The Wi-Fi 101 is a driver to connect to an older Wi-Fi board, and the MKR1010, which has its Nina module, has to use the WiFiNINA driver file. So this needs to be modified, and you should write here Nina instead of 101. This is the big change that needs to be made. And if you have installed the WiFiNINA library properly, you will see how the color of the WiFiNINA word changes, because it's a reserved keyword, which means everything will be good. So WiFiNINA and Wi-Fi 101, just to make it clear, have the same collection of methods available for the next layer, which is the ArduinoHttpClient library to connect to it. Then what this example will be doing is to look for the server echo.websocket.org and try to connect to it. And then on top of that, it has to be done on the port number 80. So WebSocket can use any ports to communicate with, but is created to mainly work on port 80 for an open HTTP communication, or 443 for HTTPS communication. But again, you can move it to any other ports. In particular, I will move it later to a different port. But we're going to run this example just to make sure that everything works, that we can communicate to this echo.websocket.org server, and that we can get data back. You will have to configure also the Arduino secrets with the proper Arduino SSID, the proper SSID for your network and the bus for your network. Because I don't want to have to type this live on this livecast, I have already prepared a file where I type this properly, and I have it here. So I will not show you the Arduino secrets tab, but here I have just changed that part and everything is working fine. I just double check again that I have everything in place and upload this to my board. So just to make clear what's going to happen now, whenever I open the CR port monitor, I will be seeing this board trying to connect to the server echo.websocket.org over the port 80, open a bidirectional communication, and then it will try to be sending the words hello and a variable that is keeps on increasing a counter. So we'll send hello 0, hello 1, hello 2, hello 3. And if the server is working, since it's just echoing the signal back, it will be sending the information back. And we will be able of reading this on the serial port monitor. So let's take a look. And let me just bring in here, you see sending the message and receive the message. So it keeps on sending and receiving. We just didn't see on the window when it's communicating to my network because I didn't really want to show the SSID, but you see how it's working perfectly. So the communication is working, and this means my Arduino board can send, being a client, something to a WebSocket server and get something back. And the question is, can I then send and receive something into my own computer? Well, the answer is yes, and it's actually really easy to do. But it took me some time to get it done for a very simple reason. My laptop here is pretty secure, and it has not just the Windows Defender, the firewall, and so on and so forth. On top of that, it has a McAfee protection that I have to disable in order to make this video. If you have a bit of time, instead of just disabling your network, so your network's firewall, what you should do is to create a specific case for the right port that you're going to be using. So let me just turn this off very quickly. And while I do this, we're going to be looking here at changing this program a little bit, because instead of connecting to the WebSocket server, we will be connecting to our own server, which is our own computer, and now we're going to use a different port. In this case, I will be willing to use a port 8080. In parallel, in processing, I need to use a program called Websocket Server, and Websocket Server requires to install a WebSocket library for processing, and there is two to choose. So I'm going to show you which one you should install. So in processing, like in Arduino, you could go to Sketch, Import Library, and open the Contribution Manager, which is this one. The Contribution Manager in processing allows you to install not just libraries, but also different modes, which means you could program in the same code, but export for Android, for example. You could use different tools and different examples. So we're going to just use the WebSocket. And you see there is two different libraries for WebSockets. One's called Space Brew P5, which was created by a couple of designers working at Rockwell Group back in the days, and later at Microsoft Research. And it's an open source library for you to connect things to things. But the one we're going to use is one that is called WebSockets. It's a very simple and clean library that allows you to make a WebSocket client or a WebSocket server in your computer in a very easy way. It's the one that made by Lasse Steenbok Vestergaard. So we recommend you, or I recommend you personally, to install that one, and we're gonna see how the very easy example of a WebSocket server looks like. And here you can see that once you import the WebSocket library, we are now in processing. I'm sorry, I will put this a bit to the left so you can see it better on the screen. You create a WebSocket object, and you connect to a certain WebSocket. In this case, we're going to use the port 8080, as I said, and we're going to use no folder to connect to. We will connect directly to the WebSocket. This will create a WebSocket on the port 8080 in this computer, and it will be drawing an ellipse every 5 seconds and sending a message saying server message. And if it happens to get any messages from a client, it will print out that message and change the coordinates that it's using to paint the ellipse. So the ellipse will be moving every time it gets a message from a WebSocket client. So I could just start running this example here, and it should run no problem. And it says here that the server started, but it doesn't really tell me the IP number, and I need to know the IP number for this to work. So what I'm going to do is to go to PowerShell. This is a Windows computer. If you were in Linux or Mac, you should just go to terminal and issue the command ipconfig. ipconfig in Windows is going to tell us the IP number for each one of the different network interfaces in the computer. If you were in Linux or Mac, you should issue the command ifconfig instead of ipconfig. Okay, it's very important. And here you can see that the network IP number for this computer here is 10022. So taking into account that it's 10022 and that this computer is on the same Wi-Fi network as the board here, okay, both of them have to be in the same network, otherwise it's not going to work. Or the computer needs to have a public IP address, which is very unlikely. Then we can just use that number to reconfigure this part here to be 10.0.2.2. If I remember right, I closed my my PowerShell, but I'm gonna open it again and just double check this thing because I want to be 100% right on this. ipconfig and 10022. Okay, perfect, that's it. So I don't really care about the IP number the Arduino board is going to get. It's not that important. What matters is that the board gets the right IP number to this server. And once the server is running, by the way, I forgot to tell you, if the server is running properly, you're gonna see something like this. This is a very tiny window. And this is the server running right now, and you see here that small white thing, that is the area that is responsible for is an ellipse, sorry, that's the ellipse that is being shown. I'm gonna put this under my picture and I will tie up that window there. I have this pin application on this Windows computer that allows me to copy a feature that all Linux computers have, which is like to keep a window always on top. So, okay. So then, as I said earlier, I need to turn off just for a while my McAfee, and I was doing that, and here it is. So I will just turn it off for just the 10 minutes I will test this. This test will last. Okay, you can see this how I'm doing it, but I basically turn off the firewall just because I want to have the port 8080 open. I could just go around reconfiguring the settings and so on, but I don't want to have it open at the end. I just want to have it closed. I just want to show you how it works for this case. So this board here is ready to be configured with these new settings, which is the new IP number for the server and the port, and I have no firewall right now checking out that particular port. So I reconfigure the board, and then I will open the serial port monitor and I will check that everything is working as expected and that the board is sending something to the server and getting something back. Okay, so right now the board is connecting, and here we have the serial port monitor, and it's sending a message. And as it sends the message, you see how the message is being received because the processing sketch is changing the location for the circle. Let me just open this so you can also see here how the messages are coming in down there on the processing debug area of the window. So the board is sending. At the same time, the server every 5 seconds is sending the message, server message. So you can imagine that now you could have whatever sensor on your Arduino board and send it as plain text all the way up to the computer, and it will work fine. So this was a very easy example on how to open a WebSocket. You remember you need to use a couple of libraries, both on Arduino, on processing that don't come by default. And you have to use this very tiny trick where you have to use the ArduinoHttp library and change the simple server socket example, simple WebSocket example, so you can make it work for the WiFiNINA, which is the wireless driver that you need for the Arduino MKR1010. So this was it. Thank you very much for watching, and just remember that this week is the Arduino anniversary. It's Arduino Day during this weekend, and my partner Massimo will be having an AMA and ask me anything. Just follow the Arduino Day information for it. Remember to subscribe to this channel, to like this video, and to follow us on our Discord channel. Thank you very much, and see you soon on the internet.